Hello everyone, welcome back to my channel Study With Me. Today I'm going to explain about Chemistry Standard Level Paper 2, May 2022 Time Zone 1. If you find this video is helpful for your exam preparation or revision, please don't forget to subscribe and let your other friend knows about my channel to support me so you guys can study together maybe. Alright, so let's get started. When heated in air, magnesium rebound reacts with oxygen to form magnesium oxide. Write a balanced equation for the reaction that occurs. So magnesium, that would be solid, react with oxygen, gas phase, will produce magnesium oxide, that is also solid. Then we need 2 here to balance the equation, and 2 here as well. State the block of the periodic table in which magnesium is located. Magnesium is located in group 2, so that would be block S. Block S for the group 1 and 2, and then we move to transition metal. They're all block D, and then if we move further right, that would be non-metal. They are in block B. Identify a metal in the same period as magnesium that does not form a basic oxide. It's aluminum because it forms amphoteric, means it reacts with both acids and bases to form salt. The reaction in AYI was carried out in crucible with a lid, and the following data was recorded. So there is mass of crucible and lid without the magnesium, and then after adding magnesium before the experiment or heating, and the amount of magnesium after heating. So calculate the amount of magnesium in mole that was used. So this definitely before the experiment, so we need to subtract these two. It's 6.354. so to find the mole of magnesium, that would be M divided by MR. So 6.354 divided by atomic relative mass of magnesium, which is 24.31. It's 0.2614 mole. So after heating, we need to know how many grams it's produced after heating. So that would be 56.941 minus 47.372, because that would be the amount of magnesium after heating. So mass of the product after heating will be 9.569. And to find the percentage uncertainty, because we have before adding the magnesium 0.001 and after heating 0.001, so we add them both, so that would be 0.002 divided by the amount of magnesium times 100 will be 0.02%. Assume the reaction in AI is the only one occurring and it goes to completion, but some product has been lost from the crucible. Deduce the percentage yield of magnesium oxide in the crucible. So we need to find the theoretical yield of magnesium. Basically it's magnesium oxide, because it's the percentage yield of magnesium oxide in the crucible, because when magnesium is heated and some of them might react with oxygen. So N times MR, that would be 0.2614. so as you can see here, magnesium and magnesium oxide, they have the same coefficient. So if you find mole of magnesium, you will also have the same mole of magnesium oxide. So times molar mass of magnesium oxide, which is 40.31, you get 10.536 gram. So this will be theoretical yield. So percentage yield formula will be actual yield divided by theoretical yield. So 9.569 divided by 10.536 times 100%. 9.569 is the mass that you got when you did the experiment. So it's 91%. When magnesium is burned in air, some of it reacts with nitrogen to form magnesium nitride according to the equation. This will be the equation. Evaluate whether this rather than the loss of product could explain the yield found in B3. So yes, 0.2614 mole forms 10.536 of magnesium oxide. We already did the calculation here. So if we use 6.354 of magnesium, we will form 10.536 gram magnesium oxide, but it will form 9.796 gram of magnesium nitride in case it reacts with nitrogen. How do we get this? So these are the calculation. Magnesium nitride coefficient is 1, but magnesium is 3. So we can find mole of magnesium nitride by using mole ratio 1/3 times 0.2614, which is 0.087. And to find the mass, 0.087 times molar mass of magnesium nitride, which is 100.95, and you will get 8.796. So it will form 10.536 gram of magnesium oxide and 8.796 gram of magnesium nitride. So there will be loss of product. That's why it's yes. Suggest an explanation other than product being lost from the crucible or reacting with nitrogen that could explain the yield found in B3. So magnesium was partially oxidized, or the reaction is incomplete. Okay. Calculate coefficient that balance the equation for the following reaction. So Mg3, so here Mg is 3, so Mg here is 1, so we put 3 right here, and now oxygen becomes different, so this will put 1, so number of oxygen now becomes 2 times 3, so it's 6, so oxygen here needs to be 6. Now hydrogen becomes 12, so here hydrogen is 3, so we need to put 2 right here, so this will be 6, and then this one also will be 6, so the total hydrogen is 12. So now the equation is balanced. Determine the oxidation state of nitrogen in Mg3N2 and in NH3. So Mg3N2, you know Mg comes from group 2, so it's plus 2 times 3, that would be plus 6, and this should be negative 6, but for N2, so for N only will be negative 3, and for NH3, H is plus 1, so plus 3, and here N will be negative 3, so here is negative 3 and here is negative 3, so you can do this calculation right here. So the answer is negative 3, negative 3. Deduce giving reasons whether the reaction of magnesium nitride with water is an acid-base reaction, a redox reaction, neither, both. We're acid and base, yes. Why? Because in magnesium nitride there is ion and 3 minus except H plus. How? First, Mg2 and 3 will decompose or dissociate, becomes Mg2 plus and 3 minus and H2. So this one will accept proton. And what about redox? No, because no oxidation change. Okay, let me write it back, the reaction. Mg3 and 2 plus 6H2O produce MgOH2 and an H3. Okay, so Mg3 and 2, Mg is plus 2 times 3 plus 6 and 2. So for 1 Mg, it will be plus 2. N2 will be negative 6. For 1 N is negative 3. As usual, O negative 2, H2 is plus 2, for H1 is plus 1. H2 here, so it's plus 2, Mg plus 2, and O it's 2. So O first, for 1 O is negative 2, we have 2 O, so negative 4. For 1 O, negative 2, so 1 for 1 H is plus 1. Here H3 plus 3 plus 1 for 1H, N is negative 3. You see, N doesn't change, Mg doesn't change, H doesn't change, O doesn't change. So it's not a redox reaction. Most nitride ions are N14 3 minus. State the number of subatomic particles in this ion. N14 3 minus, 14 is the mass, atomic mass. So the proton number is 7. So atomic number is 7. So proton number will be 7, neutron number will be 7, electrons will be 10 because there is 3 extra electron. This is 3 negative. Some nitride ions are 15 and 3 minus, and there is a term that describes the relationship with N14 3 minus. That will be isotopes, because isotope is chemical element that have the same number of protons. They have the same number of protons because it is the same element, and different in number of neutron because they have the different mass number. So obviously we'll have the same neutron number because they have different atomic mass. The nitride ion and the magnesium ion are isoelectronic. They have the same electron configuration because, you know, nitride ion, so if number of atomic number is 7, so the electron will be 10, and magnesium 12 plus 2, number of electron will be 10 as well. So determine giving a reaction which has the greater ionic radius. It's also, you know, negative, so with the electron number that is already 7 and then adding more 3, so of course the ionic radius will be bigger compared to the one that lose electron, like in Mg. Suggest 2 reasons why atoms are no longer regarded as the indivisible units of matter. It's because they found out now atoms can be split or subatomic particles discovered, you know, proton, neutron, and electron, and particles smaller with mass less than atoms discovered. They discovered also the mass of protons, neutrons, and electrons. So you can choose 2 from these 3 because the point is the marks only 2. State the type of bonding in magnesium, oxygen, and magnesium oxide, and how the valence electron produce this type of bonding. Magnesium, between magnesium is a metal, and then oxygen and oxygen, both of them are non-metal. That would be covalent. Magnesium oxide, magnesium is metal, oxide is non-metal, then it would be an ionic bond. So the bond between metal and metal, it's delocalized throughout lattice, attracted to cations. And for covalent is shared electrons between atoms. And for magnesium oxide is an ionic bond. So magnesium will lose the electron, transfer to the oxide. So transfer electron from magnesium to oxygen, or also you can say losing electron by magnesium and gaining by oxygen. Ammonia NH3 is industrially important for the manufacture of fertilizers, explosive, and plastics. Draw arrows in the boxes to represent the electron configuration of nitrogen atom. So nitrogen atom with proton number it's 7. That would be 1s2, 2s2, 2p3. So 2 electron here, 2 electron here or spin, and then 2p3. So you need to point it out first all, filling up the orbital, and then if it's more than 3, then you will start pointing it down right here. Okay. Draw the Lewis electron dot structure of the ammonia molecule. So N has 5. Okay, and then with H they have 1. So that would be like this. Ammonia is produced by the Haber-Bosch process, which involves the equilibrium. Deduce the expression for the equilibrium constant Kc for the reaction. So that would be the concentration of product to the power of its coefficient divided by reactant to the power of its coefficient. Explain why an increase in pressure shifts the position of equilibrium towards the products and how this affects the value of the equilibrium constant. So it will shift to the side with fewer moles of gas. Okay, increasing the pressure will not change the value of Kc. Values of Kc is unchanged because when you do some changes in equilibrium reaction, as it is changed, it will minimize the change directly. So values of Kc will be unchanged. And why it is shift to the fewer moles of gas? That would be if you do or if you increase the pressure. If you decrease the pressure, that will shift to the with more mole of gas, and this will be this will be inversely proportional with volume. Okay, if you increase the volume, that would be shift to the side with the higher moles of gas. So be careful. For the pressure, increase the pressure will shift to the fewer mole of gases. Decrease the pressure will be more or higher moles of gas, and this will be the opposite with the volume. State how the use of catalyst affects the position of equilibrium. It won't be affected or unchanged because a catalyst speeds up the rate of both forward and reverse reaction equally. It does so by providing an alternative pathway with lower activation energy for the reaction to proceed, but it does not alter the position of equilibrium. It just fastens the reaction for both forward and reverse reaction. Therefore, adding the catalyst will not affect the position of the equilibrium. The effect of temperature on the position of equilibrium depends on the enthalpy change. Determine the enthalpy change for the Haber process in kilojoule. Use section 11 of the data booklet. That would be the average bond enthalpy. So the reaction is N2 plus 3H2 produce 2NH3. I always encourage you guys to draw the structure so it will be clear for you how many bonds or what kind of bonds available there. For example, for NH3, so you can see there are 6 NH right here. So N, triple bond N is 945 plus 3 times 436. So this will be 6 times 391 because 1, 2, 3 times 2. So it will be 6. So the total here, 2,253. And this one is 2,346. So delta H, this one minus this one. So you get negative 93 kilojoule. Calculate the enthalpy change for the Haber process in kilojoule using the following data. Okay, so because N2 and H2, they are in their standard state, therefore the enthalpy of formation for these two are 0, but not for NH3. So delta HF, that would be products minus reactant. So we have only products because reactants, both of them are 0. So 2 times negative 46.2, you get negative 92.4 kilojoule per mole. Okay, suggest why the values obtained in DI and D2 differ. Because it has an H bond enthalpy that is an average and may not be precise value in NH3. Okay, because NH3 we have 3 bonds of N and H, so it's using average bond enthalpy, so this is not be as precise if you calculate the enthalpy of formation of NH3. Ammonia is soluble in water and forms an alkaline solution. State the relationship between NH4 plus and NH3 in terms of the Bronsted-Lowry theory. Okay, so H2O lose proton becomes OH minus, so it means donates proton, so we can say this one is acid. So if this one is acid, this one will be conjugate base. And if this one is acid, this one will be base and this will be conjugate acid. So the relationship is conjugate acid and base. Determine the concentration in mole decimeter cube of the solution formed when 900 decimeter cube NH3 at 300 Kelvin and 100 kilopascal is dissolved in water to form 2 decimeter cube of solution. Okay, so to find concentration, we need to use this formula, but we don't have mole, but we have volume, which is 2. So to find the mole, we need to use PV and RT because there is pressure here. So so that would be PV divided by RT. So P is 100 kilopascal and the volume of NH3 is 900 divided by gas constant 8.31 times 300 Kelvin, and you get 36.1. So mole is 36.1, then you get 18.1 mole per decimeter cube concentration of the solution. Calculate the concentration of hydroxide ion in ammonia solution with pH 9.3. Okay, so water constant is the multiplication of OH, concentration of OH minus and H plus. So this one is 10 to the power negative 14. So we can rewrite the equation. So 10 to the power negative 14 divided by 10 to the power 9.3 comes from here, and you get 10 to the power negative 4.7. Okay, this OH minus, then the concentration is 2 times 10 to the power negative 5 mole per decimeter cube. Magnesium is a reactive metal often found in alloys. Magnesium can be produced by the electrolysis of molten magnesium chloride. Write the half equation for the formation of magnesium. Okay, so for electrolysis, this is the key. So positive will be anode, negative will be cathode. Okay, anode always experience oxidation, so lose electron. Cathode always experience reduction, so gain electron. And we have magnesium chloride. Okay, magnesium chloride is MgCl2. If we dissociate them, becomes Mg2 plus and 2Cl minus. So Mg2 plus as a cation will move towards negative electrode, and 2Cl will move towards positive electrode. Therefore, the half equation for the formation of magnesium, it will experience Mg goes to cathode, reduction. Okay, reduction, gaining the electron. So Mg2 plus 2 electron produce Mg, because reduction, gaining the electron. Suggest an experiment that shows that magnesium is more reactive than zinc, giving the observation that would confirm this. So you can place both metal in acid, bubbles evolve more rapidly for Mg, or magnesium dissolve faster. Okay, or no need to be or, because it's 2 points here. Iodomethane is used to prepare CH3MgI. It can also be converted into methanol. Identify the type of reaction. It's a nucleophilic substitution. Okay, because it involves replacement of the one nucleophile, which is OH minus, with another group, which is I minus, within a molecule. The OH attacks the carbon atom in methyl iodide, displacing the iodide and form iodide ion. Outline the requirements for a collision between reactants to yield product. The energy should be bigger or equal to the activation energy, and it should have correct orientation of reacting particles. The polarity of the carbon-halogen bond CX facilitates attack by OH minus. Outline, giving a reason, how the bond polarity changes going down group 17. It will be decrease or less polar, and electronegativity of halogen decreases down a group. As you go down, the atomic size increases, right? because it has more electron shells, resulting the attraction between the nucleus and the electron in the outermost shell weaken. So this will lead to decrease in the electronegative. You know, the electronegativity is when the nucleus is able to attract the electron, because the atomic size increases, the attraction will be weaker, so the polarity will decrease. All right, so that's all for the explanation paper 2, chemistry standard level, May 2022, time zone 1. I hope this video is helpful for you guys to do exam preparation and or revision. And if you find this video is helpful, don't forget to subscribe and let your other friend knows about my channel as well. So this can really support me to explain other past papers as well. All right, so that's all for today, and bye for now.